All right. Hey, today we're going to be working on page 369 to 372. It's 4 pages there, but there's really only 8 problems. The problems, like 2 problems to a page, roughly 1 to 2 problems per page. So not too much. But first, I want to start with a little review, kind of go back over this. We're at the refine section, meaning we're at the end of this lesson. And hopefully we're starting to pick some of these things up and being more comfortable with this dividing decimals concept. So I'm going to go through and review some different concepts here with this problem right here. Let's use this as a review here. So now with this, I'm saying 8 4/10 or 8.4 divided by 0.3 or 3/10. So the first thing we identify right away is that we know that both of these are written to the 10th place. The 10th place is our lowest place value that is being represented, which is important. We want to identify what is our lowest place value being represented so we can try to get them so they're at the same thing. So when we're comparing these numbers to be able to relate and divide with them, we want to know what the lowest number is. And in this situation, it's tenths. If, for example, this one was hundredths and this one was tenths, we'd want to adjust them all to the lowest one. So we'd want to, if this was the hundredths, we'd want to adjust this one down to tenths as well. Hopefully that makes sense. For example, if the problem was 0.84 divided by 0, so 0.84 divided by 0.3, we'd have 2 different place values that would be represented here. So we'd have, here would be 84 hundredths and this would be 3/10. We'd want to get this to hundredths as well. And we treat this like 30 hundredths and this one's like 84 hundredths. In both of these situations, we would then need to adjust how we kind of looked at the problem and approached it, okay? All right. All right, let's do this. Okay, so let's ignore this right now. This would get a different answer than this, by the way, because the place values are obviously in different places. Well, this one is the same number as this, but this is a different number. So it would get the same digits. We would have the same digits, but all the place values would be off by 1 place value. So, all right, so what we're gonna do is we know that this is 8.4 is equal to 84 tenths. That's what we should be thinking. That's what we're thinking through this whole process, right? We know that 3/10 is equal to 3/10. Because they're both tenths, like we already said, we can just treat these like whole numbers. So it's 84 divided by 3. 84 divided by 3. Sweet sassy molasses. Okay? So what we're going to do is we're going to divide. Now I'm going to go through a couple different strategies here. So I'm going to start with the big 7, 84 divided by 3 as a review. Start with the big 7 here. My thought process should be, okay, how many groups of 10 can I get into 80, right? How many how many groups of 3s can I get in this? So how many groups of those can I get in there? Well, I know that 10 times groups of 10 I'm talking about earlier, 10 times 3 is 30. We can go more, can't we? So 20 would be 60. Can we go more? No, because we go to 30, we get 90, so it would be too many, right? So we're gonna go ahead and use 20. So then the idea is right here, it's gonna be 20 times 3, right? And that's what that's gonna be here. This 20 is what is our important setup. That is, I'm multiplying 20 times 3, so I just wrote over here just as, so you understand what I'm doing. It's just a little extra. This would be 60. We're going to remove this. This, by the way, this is our partial quotient. Well, it is one of our partial quotients. Now, you can use a lot of different numbers, but why not use numbers that are easiest to work with? Now we go down to 4. This down to 2, so we have 24. Again, think about our multiplication facts. I know that 3 times 8 is 24, so this will be 8. Again, times 3, right? That'll be 24. Get this down to 0. Bump, done, right? Because I'm not getting any more in there. These are my partial quotients. Both of these are. I'm going to add these together. I'm going to get the answer of 28. Okay. Now, some common mistakes. Some common mistakes is our kids knew that this was tenths, for example, Oh, they're in the tenths. This is 28. We need to change this 28 and we need to change it to tenths, 2.8. Don't do that. Don't do that. Now you might, Mr. Smontress, we did that earlier in the book. You're right. We did do that earlier in the book in the situation where if the number was this, 8.4 divided by 3, 8.4 divided by 3, we would treat this like 84 divided by 3. But because this is tenths and this isn't, we would need to get to the answer of 28, but then we would need to readjust it, right? And get the decimal point in there because this number is 84 tenths. This number is just 3. We're taking 84 tenths and dividing it into 3 groups. But the idea is that's going to tell me how many tenths I have left. But because this is in tenths, so it's not kind of, the idea is if it helps you think about it as canceling each other out basically of tenths and tenths, right? So, but this one's not tenths, so it stays as tenths. That's what my total amount is that I'm separating out into groups of, right? So don't let that confuse you. You need to pay attention to what the values are. Okay, super important. Okay, yeah. So that's probably one of the biggest potential common mistakes kids are going to have. Let's see here. Another way to approach this problem, another strategy. If our original problem is 8.4 divided by 0.3. Okay, again, another strategy here is to think about this as multiplication. So I could think about this as 0.3 times what equals 8.4, right? Cool. Again, then I can look at it as 3 times what equals 84. Now this doesn't work as easily because it's not like it's a fact family and super easy to work with, but again, it can help me sometimes understand as I think about it using the related multiplication facts of it. I know a lot of you guys will use that, and in this situation, some of you guys might just use repeated multiplication to work up, which is just the opposite of this. Rather than counting down from 84, sometimes you'll work up and break it up into groups, and that's fine too. For example, some of you might think, oh, I know that that 3 times 25 equals 75. Cool. So some people want to be like, hey, I know that. How much is left over? Well, there's 9 left over, right? So if there's 9 left over, because 84 minus 75, well, I know that's 9. So I have 9 left over. How many 3's going to 9? Well, 3, because 3 times 3 equals 9. If I put these together, that gets me to my 84. This right here equals my 28, right? And that was originally the answer. Oops. That was originally the answer. So there's different ways to think about this. Again, that's the same exact thing this is, except for this is just kind of not as organized and kind of thinking up, rather counting up essentially, rather than taking away. Both strategies work just fine. This gets a little trickier, obviously, when they don't work out into equal numbers. But also you don't have to subtract. Again, think about how we can manipulate numbers and make them do what we want them to do. So hopefully that answers some nice review questions here. I am not going to go over every single one of these in this video because I want you to be able to practice. The idea is if you've been doing this along the way, you should be getting more and more comfortable with the practice of this. And hopefully you're getting more confident that you can start solving these problems more independently. Well, let's look at the example, okay? It says, Nancy ran a total of 35 miles to train for a race. So she's training for a race. Okay? She ran 2.5 miles each day. That's important. How many days did Nancy run to train for the race? Well, a total of 30. So we have a total. That's key right there, right? Remember, I've talked about this before. We want to find out, do we have a total? Do we have a total amount of whatever it is that we're dealing with? If I have a total amount and then I have whatever per day, then there's a good chance that I'm going to be, if I already have the total, then I'm going to be working out. Now, if I don't have the total, then I need to work up and it's asking me to figure out what the total is, then I might either need to add or multiply to get there. But if I already have the total and then it's broken up into these certain number of groups of, then I know that I'm going to be dividing. Or taking away, right? Which again are interconnected skills. Now, let D equal the number of days, right? So D is equal to the number of days. This is part of an answer of an example of work, right? So number of days. So how many days? This is going to be D, right? The number of days. So we know that 2.5 miles each day. So 2.5 times each day is going to give us a total of 35 miles, right? Ran. So that gives us our total miles ran. So we can think about this from the standpoint that 2.5 is equal to 25 tenths, right? Because this is written to tenths, we want to write this to tenths. Because we went to tenths, we want to make sure we get this 35 to tenths. Well, 35 is the lowest place value. There's our ones place, right? So we want to find the tenths. There's the tenths right there, right? Again, 350 tenths, right? 350 tenths, and the way we look at it. Then we can think 25 times D equals 350, which the inverse operation of that would be division. So 350 divided by 25. And if you did that, you would get to 14 using the strategy that we just talked about. And so again, make sure you're getting to the same place values when you divide this. Okay, not the same number of digits in the number, okay, but the lowest place value that is being represented in the number. Okay, in this situation, the lowest place value was tenths, because this is 2 and 5 tenths, and this is just 35. Well, the tenths place is the lowest place value that is being represented, that has an actual value, right? So then I would adjust this into the 350. Okay, I will do number 1 with you guys here. Okay, it says what number multiplied by 8 will give a product of 9.6. Write an equation and solve. Okay, so let's go and do this one together here. So what number multiplied by 8 will give you a product? So let's just write that as equation. This sentence right here is really an equation. So it's really giving us an equation here. So let's think of what number. So we'll say that's question mark for now. We can use a variable if we want. Let's just put a question mark. That's fine. Okay. What number multiplied by 8 will give us a product? Product is the answer to a multiplication problem, right? So therefore it will equal the product, the answer to a multiplication problem of 9.6, correct? So that's what we need to be thinking. What times 8 equals 9.6? Well, I know a lot of multiplication facts, and there's none of them that equal 9.6 times 8. So we need to do some more critical thinking here, right? We can use the inverse operation of 9. So we can go 9.6 divided by 8 will equal my question mark, right? Okay, cool. So we probably should go ahead and get these to, well, let's just think logically real fast. Let's just do some estimation really fast here, okay? If I do some estimation real fast, I know my answer is going to be bigger than 1, because 9.6 divided by 8, right? 9.6 divided by 8 is going to give me a number that is greater than 1, because 9.6 divided by 9.6 would be 1, right? And so I'm dividing by a number that's less than, so I'm going to get a number that is going to be greater than a whole, correct? Okay, so that's good to know. Okay, is the number going to be like a lot bigger than 1? No, right? It's going to be really close to 1. It's going to be right around that area, because we go 9.6 divided by 9.6 is 1, and 8 is not that much smaller. Okay, so, and we think about this as far as this multiplication goes as well, right? 1 times 8 is 8, so we know that's going to be a bit bigger than 1. If it was less than 1, then we know it's going to give us a number smaller than 8, right? So we know it's going to be right in that ballpark. So we're using that estimation strategy to at least know if we're in the right ballpark here or not. Okay, so now we can look at this as, this is how many, well, the lowest place value we have here is tenths, right? So this is 96 tenths. 96 tenths, we're going to divide this. Well, we want to get them both so they're in tenths, right? Well, 8 is how many tenths? Well, if I go ahead and I create that to the tenths place, I now have 80, don't I? 80 tenths. So I'm looking at 96 divided by 80, right? I can do that for sure, right? Or, 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 I'm kind of going off that because, wait a second, this was a whole number, wasn't it? That's right. I don't need to do this, do I? I don't even need to worry about that, do I? I can just treat it as a whole number of 96 divided by 8, and then know my answer is going to be tenths, right? That's even better, isn't it? Make life even easier for us. We don't need to adjust this, okay? We can just do this, can't we? Okay, so again, let's go and do 10, because 8 times 10 is 80. I'm going to subtract here. I'm going to get 16. Now, hopefully you're seeing a related number here, because 2 times 8 is 16. Gives me a 0, so this equals 12 tenths. Well, what's 12 tenths equal to? It's equal to 1.2, right? And that should be your answer. So yeah, see, I almost made the mistake that I talked about earlier, right? The idea is that because this is a whole number, I don't need to convert this, right? So that was silly to say that, okay? The idea is it's just divided by 8, but it is important to get this, but that is it's tenths divided by a whole number, therefore that's just making 8 groups of that, right? So again, this should work out just fine, 1.2. So 1.2 times 8, we can check our work real fast, 1.2 times 8, okay, it should equal 9.6, right? So let's look at this. 8 times 2 is 16. Regroup using the standard algorithm. 8 plus 1 is 9. One place value, 9.6. Check, right? Obviously, you can always pause and you go back, things like that on this video as you need to, okay? So you then should independently do pages 370, 371, and 372, okay? Do these before you come see me, if possible. At least try them. And if you're feeling like, oh man, I did it, but I don't feel very good about it, circle it so you know that when you come talk to me, you can focus on that rather than, oh, Mr. Sponge, I don't know what I'm doing. Well, did you try? Maybe we're trying, especially at this stage, where we're at the end of this lesson here, right? So we're at the end of lesson 17 now. And so hopefully we're the goal is to become more and more independent, slowly releasing you to independence. And so I will post another video that will talk about, at least if nothing else, I'll show the answers so you can check your work and things like that. Okay. All right, guys, I will talk to you later. Bye.